Okay, guys, so this is the Moon Lab. It's not too difficult. Most of the stuff that I am talking about will just, you're going to transfer it to your paper, but what we're going to do right now is talk about the moon and how it goes around the Earth and whenever it rises and sets and transits. And it's actually kind of cool because you can tell what time it is at night whenever you see the moon. So we're going to start off with this view of the Earth from the North Pole. So the Earth rotates counterclockwise, and most of the planets rotate counterclockwise, except for Venus, and we'll get into that later. But um, the thing that I want you to know is that whenever we look at the lab and it talks about rise time and set time and transit time, I want to use these general definitions. So, for instance, noon. So, this is the sun. So, whenever the sun is right above us, that's noon. We're not going to talk about like 12 o'clock or 1 o'clock or 11 o'clock or something like that. We're just going to use the general term noon, right? So, we have noon and then afternoon. So you can imagine yourself on the Earth. The Earth is rotating counterclockwise. So afternoon is here. And then we have sunset. So as the Earth rotates, sunset would be when the sun is right on the horizon or just past the horizon. And you can see this line right here. Whenever we go into darkness, this is called the terminator. So, um, so we have sunset, and then we have evening. We're going to use that term, evening. And then midnight. So whenever we are directly opposite of the sun, that's midnight. Normally you would think of that as like, you know, 12 a.m. or something like that. And then we have just the generic term night over here. And then we have sunrise. So the sun is starting to rise on our horizon. And then we have morning, and then we're back to noon. Okay, so we're going to be using these terms in the lab, not not any specific time, just a general time. Okay, so looking at the moon, so the moon orbits around the Earth, and when the moon is aligned with the sun, we call that phase new moon. So this is the phase that I want you to start your lab with. So new moon is here, and you'll see it's completely dark because the sun is illuminating the side of the moon that is opposite of what you would see on Earth. So the new moon is basically right along with the sun. So this is west, but it doesn't matter where the sun is in the sky because the moon orbits the Earth. Basically, in 1 month, there are a few different definitions for that: the synodic month and the sidereal month. The synodic month is about 29 and a half days or so, 29.531 days. But so every month, moon month, that's how we got that term, is about 29 and a half days. And synodic means that the moon returns to the same place that the sun is every month. And then you have sidereal month, which you hopefully have read about, where the moon returns to the same place that the stars are every month. And the sidereal month is about 27.32 days or something like that. So it's a little shorter than the synodic month. And that's because the moon has to go a little extra to get around to the sun, because as the earth is rotating and orbiting the sun, the moon has to catch up just a little bit more every time um, to be in the same place that the sun is. But anyway, so the new moon and the sun are in the same place in the sky. And it like, this is why online teaching kind of really sucks is because if we were in the classroom, I would give you tennis balls and you would use the tennis ball to simulate the moon going around your head, like your head would be the earth, and you would see how these phases would play out, but sadly we can't do that. Um, so here we have a waxing crescent. So this is what you would draw in the second little circle. You would have the waxing crescent, sorry. And why that is if you were to draw a line tangent to this circle, you can't see the other side of the moon, but as the moon goes around, orbits the earth, you can see a little part of the moon right here, just a little part. And even though it looks like it's, halfway cut off, the only part you can see is this little shaded part here. So, oh, I should go back actually. Let's go back to this new moon right now. So on your lab, whenever it says that something transits, it means that it's crossing your meridian. Remember, your meridian is the line directly above you that cuts the sky in half from north to south. So new moon transits at noon. Okay, so that's when the new moon is crossing your meridian that we learned from the star chart lab. When the new moon rises, let's go back. Oops. When it rises, so the new moon transits at noon and it rises to before. So it rises with the sun at sunrise and it sets to after. So it sets at sunset. You see? So right now, this new moon, these are everything that I'm going to show you is at transit. So waxing crescent, where is that transiting? Where is that crossing your meridian? Right? So I'll give you a second to think about it. It's at afternoon. That's that general term that we used. So waxing crescent transits in the afternoon. Where do you think it rises and sets? So I said it rises 1, 2 before. Do you remember what this was called? This line right here? That was morning. Okay. So it rises in the morning and it sets. What was this called? This was in the evening. Okay. So I'm not going to give you any more information about that. Just remember, whatever I show you right here is when it transits. We can go back to that first slide over here. So the waxing crescent transits in afternoon and it rises in the morning and sets to later in the evening. Okay. So it's like a 90-degree kind of T shape here. And you can see when the sun is rising, let's say, you can see right here that we have this kind of 45-degree angle between them, between the waxing crescent moon and the sun. And it doesn't matter where the sun is in the day. It could be right above head. That waxing crescent moon would still be that same angle. It is moving a little bit, but just in general, that's the point of this lab, is just generalities of where the moon is in relation to the sun. It is the same angle. So first quarter, right? So first quarter is right here. If you were to draw a tangent line on this circle, you can't see the backside of this moon, but you can see that the moon is half illuminated. So this is first quarter because you can only see 1/4 of the moon illuminated. And then this is the third circle that you would draw, and you would tell me when it rises and when it transits and when it sets. Okay. So you can see the first quarter is exactly 90 degrees from the sun. It does not matter where the sun is in the sky, but that is where first quarter is. So we have waxing gibbous next. So waxing is whenever the moon is getting more light. Basically, it's more and more light throughout the month. And gibbous means like a football or an egg shape. So this is a gibbous moon. So this would be the next circle that you would draw in. And you can see that we can see most of the light of the moon. There's a little sliver of light that we can't see here. If you were to draw a line, you can't see the backside of the moon, but there's a little sliver of darkness here. And again, you would tell me when this transits, when it rises, and when it sets. So waxing gibbous is over here. This is basically where the sun, this is in the west. The sun is setting, so the waxing gibbous has risen a little bit before the sun is set. And then here we have the full moon. Now, just to give my personal opinion, I'm not a fan of full moons. They block out a lot of starlight and they're up all night. And I will, just tell you right now. Here's a little freebie. Right, the full moon transits when it transits at midnight. So when the full moon is high above head, it's basically midnight. So it rises to before. So it rises at sunset and the moon sets at sunrise. So the moon is up, the full moon is up all night, and I don't know. I'm not a fan of full moons. That's just me as an astronomer. I like to see stars, and the full moon is very, very bright. Its magnitude, something like negative 12.5. And even if you were to look at it in a telescope, it's not very interesting. Looking at the moon in the telescope, you want to look at it in a crescent view or something like that because you can see shadows of craters and stuff. I don't know. Okay, I'm gonna stop my rant on the full moon. Um, but the full moon is completely light, basically. So what? By the way, what you're going to do with these circles is you're going to be shading in the dark parts. So you would not shade in anything of the full moon. And so you can see when the sun is setting in the west, the full moon is rising in the east. And when the sun is rising in the east, the full moon is setting in the west. So that's kind of how that works. So now we've kind of flipped things. So now we're getting into the early morning kind of aspect of it all. So we have waning. So waning means the light is fading, it's waning. So we have waning gibbous over here. So you can see that the shadow part is on the right. If you were on the earth over here, we have waning gibbous. And you can refer back earlier in the video of what we called this this era. I believe it was night, just night in general. But this is waning gibbous. You can see the waning moon is illuminated on the left side. So as the sun rises in the east, this is about to set in the west. You can imagine this thing rotating. In this particular situation, the sun rises and sets in the west, so it's going clockwise, but we're looking south. So if we were looking north, it would be opposite. Just get that in mind. So last quarter, also called third quarter. We can only see, um, you know, again, 1/4 of the moon, but it's the last quarter. By the way, full moon, you could technically call that half moon because we can see half of the moon illuminated. We can never see all of the moon at any given time. And in fact, we'll get into that here in a minute. But this is the last quarter. Um, th- you will tell me when this transits, at what, time of day. Um, remember what we called this area here, when it rises and when it sets. So you can kind of like, so the moon rises in the east and sets in the west, just like everything ever. So you can kind of get a time of day. For instance, I'll give you this one, right? Like the last quarter rises at midnight. So if you see a quarter moon and it's on the eastern horizon, then it's about midnight, right? Like you can get the time of day for where these different moons are if you know the phases of the moon. If you're like, oh, that's gibbous or that's this or that, you can get the time of day, and I say day in the general sense of a 24-hour rotation period. You can get the time of day or night or whatever you want to call it, um, by knowing what the moon looks like and where it is in the sky. So it's kind of neat. It's kind of neat. So if the sun is about to rise in the east, the last quarter moon will be right above you. It'll be transiting you. And then finally, we have waning crescent. So waning crescent is here. It's exactly like waxing crescent, but opposite. And you can see when that transits, that time of day that we talked about at the beginning. And here you can see the waning crescent has just risen a little bit before the sun. And you can see that in the early morning, basically. You will never see a waning crescent at like 6 p.m. or something like that. And then we're back to new moon. You cannot see the new moon, but as you will read in the chapter, the new moon can sometimes block out the sun. We had a total solar eclipse a few years ago that I went and saw in Columbia, Missouri, which was really, really cool. And there's going to be another eclipse in 2024, I believe, that's going to go right over Dallas. So it'll be really neat. And the new moon rises with the sun in the east, and it'll be with the sun throughout the entire day. So these are the lunar phases. We have the lunar or synodic month is about 29.5 days, 29.531 days, if you want to get super technical. And these are the things that you will draw on your lab. And you're going to tell me when they rise, when they transit, and when they set. So, just a little bit more in depth here. This phase, I'm going to give you a few freebies. This phase is first quarter. So here, like I said, we would draw a tangent line. It rises at noon. So the moon goes counterclockwise. So the moon rises at noon. First quarter rises at noon. It transits at sunset. So if you see a first quarter moon that's directly above your head, it's at sunset. And sunset's at what? Let's just, in general, maybe 6, 7 p.m., something like that. That's why we use these general terms, because it's, we have daylight saving time, and the sunset and sunrises at different times during the day throughout the entire month. So that's why we use these generic terms, right? So it transits at sunset and it sets at midnight. So if the moon is on your western horizon point, and it's a first quarter moon, you can only see about half of the visible part. You know that it's about midnight, and it's kind of neat. It's kind of neat. Waning gibbous over here, you can see that you can see most of the moon in a little sliver that's dark. And if we go over here, we go back a few, we can see that the rise time is in the evening. So it's after the sun has set. The waning gibbous will rise, and this is kind of what it looks like. I do not want you to draw this. I want you to draw the other pictures that I showed you a little bit ago. But this is what it would actually look like in the night sky. And it transits at night. So remember, we called this point night. And it's going to rise in the morning. So I want you to draw those on your lab sheet that I gave you. The moon also orbits around the Earth in what is known as synchronous rotation. So, what that means is that does the moon rotate on its axis? Yes, the moon does rotate on its axis. It rotates once every month. What that means is that if you were to stand on the moon, you would orbit one rotation, one full rotation every orbit. So that's what is known as synchronous rotation. If you this point, this little triangle, is the same point on the moon. So you can see that the moon does orbit. So here we're facing directly left. Here it's kind of southwest. Here it's directly south, southeast, east, northeast, north, northwest, and finally west. So does the moon rotate on its axis? Yes, it does. It does once every month. And we can only ever see one side of the moon. In fact, until the 1960s, when we sent a satellite up there to orbit the moon, that's the first time we have ever seen the backside of the moon. We only ever see one side of the moon because of this synchronous rotation. So it said, would the Earth rise and set as viewed from the moon's surface, the moon's near side? Okay. So would you ever see the Earth set, like by set we mean going over the horizon? Would you ever see that? And that's a question on your lab, and I want you to think about that. Would you ever see the Earth set? So imagine you are standing on the moon at this point and you're rotating around. Would you ever see the Earth go out of the sky? It's an interesting question. And whenever we talk about, in my favorite album, like ever, is Pink Floyd's Dark Side of the Moon, what do they mean by the dark side of the moon? Is the dark side of the moon the hidden side of the moon? Well, what people normally think of as the dark side of the moon is the other side of the moon. Well, is that always the case? Is the far side of the moon the dark side of the moon? Well, look right here in the new moon. So the dark side of the moon is actually facing towards us, and the light side of the moon is actually facing towards the sun. So what is the moon's hidden side? Is it the dark side? No, it's not. Not necessarily. And in fact, in only one situation, the moon's hidden side, by hidden side we mean the side that we can't see, only in this situation over here is the moon's hidden side the dark side. And so that's what I have for you. Just remember, draw these. These are the figures I want you to draw, and I want you to tell me when they rise and set and transit. And I went over that with these slides. So this lab isn't too hard. I really wish we could have been in class and used the tennis balls to simulate, you know, how the moon actually looks as it's going around the Earth and the with respect to the sun. But sadly, you know, the COVID's got us and everything. So okay, I'm gonna stop it there. Comparatively, fairly short video. So good luck. See you on the message boards.